Acid rain comes from the reaction of sulfur dioxide gas with water. How many moles of H2SO3 could be produced from 1.0 times 10 to the 10th liters of SO2 at 1.000 atmospheres and 100.0 degrees Celsius, released from a certain Nebraska power plant in 2014? Well, the first thing I see is a reaction. And if I look at it, I have one sulfur on both sides, two hydrogens on both sides, and three oxygens on both sides. This is already balanced. Now, looking at the problem, I see one volume, one pressure, and one temperature. Nothing's changing, so I'll need to use the ideal gas law. PV equals nRT. Well, my pressure is the 1.00 atmospheres. My volume is in liters. That's already in the right unit. So I can use 1.0 times 10 to the 10th liters. And I'm wanting moles, so I'm going to leave N alone. R is 0.0821 liters atmospheres per mole Kelvin. And my temperature, well, that's given in Celsius, so I'll need to convert that. Kelvin equals degrees Celsius plus 273, which would be 100.0 degrees Celsius plus 273, or 373.0 Kelvin. Now, if I solve for N, I need to bring these two terms to the other side. So I'll end up with 1.000, 1.0 times 10 to the 10th power, divided by 0.0821, and divided by 373.0 Kelvin. So 1.000 times 1.0. Now on our calculators, to do the scientific notation, we can use the EE, or some calculators will have like an EXP button. But I can do this, and the E takes care of the times 10 to the part of the problem. Now I can simply divide by 0.0821 and divide by 373.0, so that my final answer, now I have four significant figures, but only two significant figures in my volume, so I'll call this 3.3 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8 moles. Now, we have one more step to do in this problem, though. These numbers were for SO2 gas, but the problem's asking us for moles of H2SO3. We need to go through and do a stoichiometry step to switch into the correct chemical. So we have 3.3 times 10 to the 8 moles of SO2. And from the balanced reaction, we can see that 1 mole of SO2 is equivalent to 1 mole of H2SO3. This gives me 3.3 times 10 to the 8 moles of H2SO3. And this would be our final answer. Now, you may also be noticing that this is the same number that we had really in the previous step. That's because the balancing came out to a 1-to-1 ratio for each chemical. If that had been something else, a 1-to-2 or a 3-to-4, or something of that nature, this number, our final answer, would have been quite different. It's good to go through and get into the practice of going through and even doing the conversions when you know that it's not going to change the number, because that will help practice and help train yourself so that when the coefficients are different, you'll still be in the habit of doing the step and you won't miss points later on.